Hey everyone, Geophysicist Stefan Burns here. Our energetic system here on Earth, even for our entire solar system, is incredibly finely tuned. And it wouldn't take that much to tip it out of balance, especially at the cosmologic scale. And well, we have Betelgeuse just nearby, one of the brightest stars in the night sky. It's the 10th brightest star. It is the brightest star in infrared. It is a red giant, just 400 to 600 light years away, and it is on the edge of supernova. At any moment now, today, tomorrow, 100,000 years from now, we're talking about the cosmologic timescale, it could explode. Perhaps it already has, and we're still waiting for that light and energy to reach us. So if all of a sudden we see one of the brightest objects in the sky, then we know it has happened. And more people are thinking that the explosion, the supernova of Betelgeuse, is coming soon. And some potential evidence for that was the great dimming that occurred in 2020. And so today's video, we're going to examine Betelgeuse and talk about its characteristics, the chance of it going supernova, what that could look like, and we'll explore more of this great dimming that occurred end of 2019 and 2020, because there are some interesting connections between that event, about 600 light years away, and planetary resonances that are unfolding here on Earth at that moment in time. So with that, let's jump right in. Here we have a before and after the great dimming of Betelgeuse in 2019. Here is the after. We see just how much its brightness has been reduced as compared to its before in January of 2019. This is the dimmest that we have ever seen Betelgeuse across our observational record. We have a couple ideas as to why this great dimming occurred, but at the end of the day, we really don't know. These are just ideas and they make sense, but we could be totally off base. But this is what we observed around the end of 2019 going into early 2020, is that the brightness of Betelgeuse dropped significantly. And well, we know that Betelgeuse has some very unique properties as a result of just overall its size. It has this boiling dynamic to it where there's these large bubbles that can be even larger than the orbit of the Earth in size, either increasing or decreasing. So these bubbles can expand out or contract at incredible velocity, 30 kilometers per second even, which is much faster than any spacecraft that we have. The fastest ever object we observed was interstellar object 3I Atlas at 68 kilometers per second. So that just shows you how fast this boiling dynamic is. We don't have the best optical views of Betelgeuse just because of its distance and just because it's difficult to get really high quality video or footage of any of this stuff. We're really pushing the limit of our telescopes, but we do see across time with our measurements this boiling dynamic exist. And that is quite clear, and that really is a clear sign that it's pretty unstable and could be ready to supernova any moment in time. Because it is 400 to 600 light years away, it could have supernovaed 200 years ago, and we won't know for another 300 years, because we're only seeing the light as it hits us. Now for the light photon, no time has elapsed, but for us, it's been, let's say, 200 years. So we're not going to see it until it's actually happening for us, and it happened for them, or for Betelgeuse, again, let's say 500 years ago. And when that occurs, whether that's tomorrow we see it or whether it's 100,000 years from now, we're going to be receiving a huge influx of light energy, because often when we see supernovas, they're from other galaxies. Very rarely we'll see them from within our galaxy, and if it does occur from within our galaxy, typically it becomes a very bright object in our night sky. 1054 AD is a classic example of that, and the supernova of the Crab Nebula, which was a dramatic event picked up by people around the world, and it was one of the brightest objects in our sky for months. Well, Betelgeuse is even closer at 400 to 600 light years away. So depending on its angle, we could also get hit with the jets produced by that. We wouldn't know till it happens. So this is a very serious thing, unlikely to occur in our lifetimes, but there are more and more people thinking and kind of feeling into that, and they're kind of picking up that that could be a thing. And again, as we look here at the dimming, we are seeing unusual dynamics unfold with Betelgeuse at this moment in time that we've never seen before. Here we see the observational record for light measurements of Betelgeuse going back to 1900. You see that in general it has a variation of about 1 magnitude, but here is the great dimming where it dramatically dropped down there, and now it is back to normal. Again, that was the end of 2019, beginning of 2020, a very dynamic time period for all of us here on Earth. We can look at a more close-up view of this data here. There is that great dimming right there. You see that it actually extended down into about February. So that graphic that we saw showing December 2019 was not the dimmest that it got. That was more around the end of January and the very beginning of February before it went back up. And if we zoom in even more, we see this is that light curve variation across time. So again, right there at the very beginning of February is when that great dimming was the strongest. And I find that significant because, just as a quick side note, we had an incredibly powerful planetary alignment at that moment in time. So let's scroll back to the end of 2019, beginning of 2020, right about here. We'll zoom in and you'll notice this incredible alignment of planets. So here is the Earth, and we'll zoom right here to about February. And you notice that we have this Saturn-Pluto conjunction at that moment in time. And that really clicked in on the 12th of January right here. It was actually a Earth-Sun-Mercury Ceres Saturn-Pluto conjunction all on a line, as you can see. And then that was right in the middle of this whole great dimming period. You go forward to when it was at its absolute lowest for Betelgeuse, early February. We see that it's still very much active in play. So coincidence that we had this incredible planetary alignment at that moment in time. We had the great dimming. We also then had the whole COVID pandemic right at that time, which very much was a great dimming of society, you could say. I don't know. Personally, I don't believe in coincidence, but you can make up your own mind. I'm just presenting the observations that we had with Betelgeuse paired with the planetary resonances that are active and also some of the societal factors. But let's learn more about Betelgeuse because it is quite an odd star, and also some of the explanations for the great dimming. So here we have the core facts for Betelgeuse, the anatomy of a supergiant. Its surface extends out beyond the orbit of Jupiter. It is about 17 to 18 times more massive than our star, the Sun, though it began with more mass originally, about 18 to 21 times. That is based off our estimates of how much fuel it's been burning during its lifespan. It's currently burning helium in its core, and there is probably a time frame of up to about 100,000 years from now when it could go supernova, though really at any moment in time it could go supernova. It's an enormously fast spinner, so rotates with an equatorial velocity of 15 kilometers per second, which is incredible, especially considering its size. And it has this variable brightness, which has about that 400-day period, which we saw with the earlier data. Its magnetic field is not that strong compared to our star, about 1 Gauss, though it is, of course, a huge star. So for it to have a magnetic field that strong over such a wide zone is pretty remarkable. And for reference, Earth's magnetic field is 0.23 to 0.67 Gauss, but we're much more condensed with our planet. And of course, if you have sunspots, that's going to greatly amplify that magnetic field strength up to maybe hundreds or thousands of Gauss. So these are the core stats for Betelgeuse, but there's also some odd stats to it. It has that unusually fast spin, up to 150 times faster than a star that's predicted for its size. So it's spinning incredibly fast. We really don't know why. It's also going through space really quickly, about 30 kilometers per second. That is not slow. That is relative velocity compared to us, but this shows that it has a lot of energy to it, not only with its spin, but also just simply with its trajectory. So one of the leading ideas is that it originally was part of a binary star system. Almost every single star that we see in the night sky is a binary, about 90% or more. And that what happened was the bigger star, Betelgeuse, eventually kind of fused with its binary, and that binary spun in and made it to Betelgeuse's core, making it a super, super fast spinner. And then it also had this ejection from its birth cluster, because stars what we see, at least with our observations, is that they form in these star clusters, and then eventually they all kind of spread out and go their own way. So it's very similar to what we actually do in life and different animals and such. So it somehow had this dynamic evolution where it got flung out at a really high velocity, and maybe this binary merger explains that. The two stars, if that was the case, actually combining caused this rapid dynamic evolution out of the star cluster. So a good example of a star cluster would be like the Pleiades. But the Great Dimming is its own whole mystery. On November 2019, it was still very bright. By March 2020, it was very dim. Again, its dimmest was in February of that year. Historic, never been seen that dim before with its apparent magnitude or its absolute magnitude. And it was really focused in the southern hemisphere. So it wasn't homogeneous across the entire star. It was localized more to the southern hemisphere, which is quite odd. So the two main ideas, and it could be a combination of this or something totally different, is that A, there was this gas bubble that was ejected from Betelgeuse. Remember that boiling surface, all those bubbles? Maybe one of those actually kind of launched off, or is a huge coronal mass ejection, like unbelievably large, that then settled in front of Betelgeuse. As it cooled down, it blocked some of the light from the star, at least based off of our view of it. Another idea is that there was a giant cool spot on Betelgeuse, like a massive sunspot, which then reduced the surface temperature and brightness significantly enough that we saw a dramatic reduction in its brightness compared to its historic observational record. And that could be due to internal convection dynamics of the plasma and more. Or it could be a combination of the two, or again, a third option is it's something totally different, right? We really haven't been looking at the cosmos that long. We have looked at a lot of different stars, but there's only so many human brains to interpret this data. And well, I would not be surprised if it's something different than this. But based off of what we know, both these explanations make sense. But really the key differentiator here is just how big Betelgeuse is. It's just unbelievably massive in size. And the fact that we had this great dimming just a few years ago, and we know it's pretty much ready to go supernova at any moment, though again, this could be 100,000 years from now, maybe even more than that. Maybe that's connected to it. Hard to say. What happens with a red giant before it goes supernova? I'm sure it gets crazy. The Great Dimming is kind of an example of something crazy happening at Betelgeuse. And we see all these other factors with Betelgeuse, which are pretty nuts already. I mean, this boiling of the surface of Betelgeuse is quite insane. And we really don't know how to explain it. The internal processes are pretty much a mystery to us, but it's barely holding on. When the star is that big, gravity has a harder time kind of keeping it together, which is why you have these dynamics. And then of course, this is all electromagnetic too, because these are all charged ions in many ways. And so you have this very complex electromagnetic puzzle that we're still figuring out. At what point does that energy just suddenly go boom and supernova out? And when it does, is it going to be aligned to us? Are we just going to see the light from that, or is an actual jet of light, gamma rays, plasma going to hit the Earth? That could be a significant trigger. At the very beginning, we discussed the Earth energy system being finely tuned, the solar system energies being finely tuned. That is all true. We have some evidence that when we have these galactic events that occur, that can cause dramatic swings in Earth's climate. I have a podcast with Raymond on the impact of supernovas on Earth's climate. It's a hypothesis, definitely worth checking out. I'll link that in the video description. But this would be some sort of trigger like that. It'd be the perfect trigger. So it's good to be aware of this. I wouldn't lose sleep over this, because again, it could happen 50,000 years from now. We have no idea. It's more just good to know and help expand your perception of the cosmos overall, to see all the dynamics at play, and how the parallels of this as it relates to your life or society, for example. But this is a factor. So if all of a sudden Betelgeuse lights up, I will let you know, though you're probably going to hear about it already, because people are going to be walking outside being like, what the heck is that? It's really bright. So if you'd like to stay up to date on everything that's happening, then please subscribe to the channel. I've been your host, Stefan Burns. Smash that thumbs up button, help the channel grow. We cover everything that's happening here on Earth energetically with our star, our solar system, in our cosmos. If you like to stay up to date, then we'd love to see you around. Thank you all so much. Wishing each and every single one of you well. Please take care of yourselves, and I'll see you all in the next video.